Now, this is an example of equation of values wherein we have to replace by the single payment of the set of obligations. So, we have a problem here wherein it says that we have to find the single payment with 8% effective interest and due at the end of 2 years that equitably replace the following obligations. So, we have the first one is 10,000 with 6% is simple interest and due at the end of 1 year and 6 months. The other one is 18,000 with 10% interest compounded every 2 months and due at the end of 3 years and 3 months. And then the last one is 23,500 with 12% interest compounded every 4 months and due at the end of 6 years. So for the given transaction to replace these following obligations, we have the interest as 8% effective. Then we can consider that the interest rate is 8% and then the conversion is equal to 1. And then if we will let the X as the single payment for these obligations F1, F2, F3, and these are the following steps in solving this single payment using the equation of values theorems. The first step is we have to find the obligations that we have for obligation 1. The amount is 10,000 or the principal is 10,000 with 6% simple interest for 1 and 6 months. So we can convert as 1.5 years because 6 over 12 is 0.5. And since the given in transaction is simple interest transaction, so we can use to find the F1, which is our first obligation, as P times the quantity of 1 plus RT. So if the value is 10,000 times 1 plus 6% to be multiplied by the number of years 1.5, then the final value of 10,000 will be 10,900 using the simple interest transaction. And then for transaction, compound interest transaction for obligation number 2, wherein the principal is 18,000. So we have the interest as 10% compounded every 2 months, meaning to say conversion period is 6 for 3 years and 3 months. So we have 3 plus 3 over 12, or this is simply 3 plus 1/4, reducing by 3, or we can also consider as 3.25 years. So we can consider as 3.25 because it is an exact decimal value. And then for the compound interest transaction, we have to look for the periodic rate I, which is R over M. And if this is 10% compounded by monthly, so this is divided by 6, so we can reduce as 5 over 3. Then removing the percentage symbol here, we have to divide by 100. So this is just simply 5 divided by 300. And then we need also the total number of period of transaction, or total number of conversion period. This is just simply M times T, wherein conversion period is 6 and the number of years is 3.25. So this is just simply 19.5. Then finding the obligation number 2 using the compound interest transaction, this is equal to P times the quantity 1 plus I raised to N, wherein the value of principal is 18,000 and the interest rate I is 5 over 300 raised to N, which is 19.5. And then using our calculator, the obligation number 2 is 20,227.08. And for number 3, obligation number 3, wherein this is another compound interest transaction, the principal value is 23,500 with an interest of 12% compounded every 4 months. So the conversion period is equal to 3. Then we have to look for the periodic rate I, wherein this is 12% divided by 3. So this is equal to 4%, or 4.04, removing the decimal symbol. And then we have the N, the total period of transaction. So we have 3 for the conversion period and the number of years 6, so we have 18. Then using the compound interest transaction, we're in finding the obligation number 3, which is equal to P times the quantity 1 plus I raised to N. The principal is 23,500 and then the interest is 4%, so multiplied by 1 plus 0.04 raised to 18. And the final amount for obligation number 3 is 47,600.69. And then for step number 2, we have to draw the diagram. And then we have to assign the comparison date, the position of the comparison date, or the CD or common date. And we have to solve the N for each value. So the first thing to do is you have to plot the given obligations F1, F2, F3 together with the single payment as X. So F1 is at the end of 1 year and 6 months. F2 is at the end of 3 years and 3 months. And F3 is due at the end of 6 years. And for the payment, it is due at the end of 2 years. So then, we can consider the common date or the comparison date position is at the point of origin, so that we can just use that the number of years from each value to the common date is the given number of years. But we have to consider that these are all discounting values, so then the N are all negative. So then finding the N for each value, wherein we can apply that this is simply M times T, and for the transaction of replacing the obligations, the given is effective, so meaning conversion period is equal to 1. Then for N1, this is just simply 1 to be multiplied by 1.5, 1 year and 6 months. So this is negative 1.5. For F2, the number of years is 3 years and 3 months. So this is just simply 3.25. So N2 is negative 3.25. For obligation F3, we have 6 years. So multiplied by conversion period once, then it is negative 6. And for the payment X, from the payment X to the common date is 2 years. So then this is just simply negative 2 to be multiplied by 1 as the conversion period. And then the next step is we have to formulate the equation of values, which is the net payments will be equal to the set of obligations. And then we have the single payment X, and this should be equal to the obligations F1 plus F2 plus F3. But there is another transaction to replace all these obligations by the given interest rate, which is 8% effective. So every value will be accumulated by the 8% effective. So for the X payment, there will be an accumulation of 1 plus 8% together with F1, F2, and F3. So we have for the payment, this will be multiplied by 8% accumulation. So this will be 1 plus 8%, and then the N of X from the common date is negative 2. And this will be equal to, for obligation F1 is 10,900 from step number 1, and to be multiplied by another 1.08% raised to negative 1.5 as the N of F1 using the common date at point of origin, and plus F2, which is 20,227.08 from step number 1 also, to be multiplied by 1.08 raised to negative 3.25 for N2. And for the F3, which is 47,606.69 obtained from step 1, to be multiplied by 1 plus 0.08, and this is raised to negative 6 from step number 2. Then finding the value of X, we have to add all the values on the right side and then divided by the coefficient of X, which is 1 plus 0.08 raised to negative 2. And then using your calculator, you will get the single payment now is 64,691.83. And then as our final answer, we have that a single payment that can be replaced all the set of obligations is 64,691.83 pesos.